Hello, my grade 9 math students. I hope that everything is going really well and you're excited for this next learning block. Today we're going to talk about parallel and perpendicular lines. And in fact, the last question that you did for the kind of weekly check-in had you doing these. So they had you doing a parallel line and then talking about if you could make that perpendicular line. So I thought that we would just extend these ideas a little bit further. And we talked about this stuff in class in that very first cycle before March break. So here's kind of the refresher video. This lesson shouldn't be super tricky. In fact, we're going to do some rules and that's pretty much it for today. So let's first talk about this equation of a line y equals 2x plus 5. So if we're considering this equation, I am telling you that y equals 2x plus 4 and y equals 2x minus 6 are parallel to 2x plus 5. And why do you think that they're parallel? Well, these lines are parallel, and some of you might see it, because they have the same slope. So because this number, our m's are the same, that means that they're parallel. Okay, so they're parallel because they have the same slope. Okay, and now if we're looking at that equation again and I'm saying y equals 2x plus 5, and now I'm telling you that y equals negative 2x plus 4, y equals negative 2x plus 5, and y equals 1/2 x plus 4, these are not parallel, and they're not parallel because look, those numbers, even though they have 2's in them, it's not exactly the same. The first two have negative 2's, see that? And this one is a fraction. Those are not the same numbers. We know that 2 and negative 2 are not the same, so these ones are not parallel because they do not have the same slope. So if I was going through this chart and I want to know if these lines are parallel to y equals 2x plus 5, if I'm looking at y equals 2x plus 3, well, those slopes, that 2x, that's the same. So yes, same slope. And if I'm looking at negative 2x minus 7, that's not the same. No, because the slopes are different. And 2x minus 7, yes, again, because of the same slope. So again, it all has to do with this number here, and you see how these are the exact same in that equation, but negative 2x, now that's different, so that's not the same, okay? So if I was looking at this and I wanted to graph all of this, because remember, everything comes back to being able to graph these, let's graph these lines, and let's graph them by plotting our y-intercept first. So I'm going to start by plotting, by graphing the green bits first. So I'm going to graph my plus 5, and remember, just a quick refresher, that this is my y-axis, this is my x-axis. So I'm going to look on my y-axis, on my vertical axis here, and I'm going to go up until I find positive 5, so right here, and I'm going to draw a dot. Okay, now my next dot is going to have to do with the slope that we see, and my slope here, my slope is 2. So what that means is from my dot that I just plotted, I'm going to count up 2 because my rise is 2. My run is going to be 1 because it's over 1. So I'm going to go up 2 over 1. So from here I'm going 1, 2 over 1, drawing a dot. Okay, and I'm going to do this one more time so I can make that straight line. I'm going to start from my blue dot. I'm going to go up 2 over 1. Okay, and then with a ruler you're going to connect those dots. So now I'm going to do the same thing, but I'm going to start at 3 because that's my next line. I'm going to go up 2 over 1. Okay, and then I'm going to start at negative 7 and do the exact same thing. And remember, I'm getting these numbers from that equation. Right. And again, so you're going to use that ruler to draw those straight lines. Okay, and if I were to look at all of these lines, they look like they're exactly parallel, so I could actually pick them up, see if it'll work, and place them over top of each other just like this, okay? So these lines are going to be parallel lines here. Okay, so in your own words, I want you to try to figure out how you can write an equation for a parallel line. right? So pick any line, and I want you to write your own equation for a parallel line to that line, all right? And again, feel free to pause the video and you can go on and do that. So now that we have an understanding of parallel lines, and remember that a line is parallel as long as that slope is the same, the y-intercept doesn't matter, let's talk about perpendicular lines. So perpendicular lines, let's see if we can figure out this pattern here. So I want to use y equals 3 over 4x plus 4 as my example equation. And I'm telling you that y equals negative 4 over 3x plus 4, negative 4 over 3x plus 5, negative 4 over 3x minus 2. These lines are all perpendicular to this one. Okay, I'm telling you that. And I'm also telling you that negative 3 over 4x plus 4, 4 over 3x plus 4, 3 over 4x plus 4 are not perpendicular. They're also not parallel, but they're not perpendicular. So can you see the pattern here? Well, one of the things that I notice is that the 4, which was on the bottom of my slope in my initial equation, is now on the top. Do you guys see that? And the 3, which was on the top, is now at the bottom. So I've flipped this fraction. Okay? And in math, we call flipping a fraction, we call that its reciprocal. Okay? So I've made a reciprocal of that fraction. I also noticed that my slope in my regular line was positive, but now my slope in these equations is negative. And let's think, what is a perpendicular line? So if I was drawing a line on a graph and it was like this, a perpendicular line is going to make a 90-degree angle with this line. So it's going to look like this. And these angles in between here, that's 90 degrees, okay? So let's just talk about this for a second. If my original line, if this line is positive because it's going up to the right, well, it makes sense that if I'm making a perpendicular line, it's going to have to go down. So it's going to have to be negative, okay? So that's where this negative comes from. So I've noticed not only am I making a reciprocal, I am also changing the sign. Okay, so I call this the good old flip and switch. Flip the fraction, switch the sign. Okay, so let's look at these to see if they're perpendicular. I'm looking at 3 over 4x plus 4. So here I have negative 3 over 4x minus 2. The sign was switched, but the fraction is not flipped. So this is not perpendicular. Let's look at this. Negative 4 over 3. Okay, the sign has been switched and the fraction has been flipped. So yes. We did the good old flip and switch. If I'm looking at the last one, 4 over 3x. The fraction was flipped, but the sign was not switched. So this one's also not perpendicular. So now let's graph these lines. So I'm going to start by graphing 3 over 4x plus 4. You start by graphing that y-intercept, that positive 4 that's at the end. So let's graph that. I'm going to put a dot right at positive 4. My next dot is going to be up 3 over 4, and I'm getting that from this slope. So remember, the top number is my rise, so up 3 over 4. 1, 2, 3, 1, 2, 3, 4. I'm going to do it one more time so that I can make a good straight line. Okay, and you're going to make a line with that. Okay, so now I'm going to do the next one. And again, I'm going to start by graphing my y-intercept, which is my positive 5. And then I'm going to do my slope. So at y equals 5, I'm going to draw a dot. And now I notice that my slope is negative. So instead of going up 4, I'm going to go down 4 and then over 3. If I go 1, 2, 3, 4, you still go right 3. 1, 2, 3, my next dot. and draw a line. And if I'm looking now, those lines are perpendicular. They're crossing, they're making a 90-degree angle. Okay, so this is a perpendicular line. These do make perpendicular lines. Don't worry about graphing the third one, it's also perpendicular. Notice that it doesn't matter where that y-intercept is. So I'm telling you that this last line is perpendicular. You're going to start it at -2. You're going to go down 4/3. If you cross that line, it's going to cross somewhere up here. It's still making a 90-degree angle. This is also why it's so important that our lines fill the whole graph. Okay? So I want you to come up with your equation. Tell me how you can make a perpendicular equation. Basically, you're telling me what the rule is up here. Okay, that flip and switch rule. So this is today's homework, or today's lesson for today. The homework is posted in the Google Doc. Let me know if you guys have any questions. I hope that you're all doing well.